Hello, welcome back to the Michigan Works Young Professionals Math Bootcamp. We are starting lesson 4, calculating fractions. During this lesson, we're going to talk about what equivalent fractions are. We are going to find common denominators, and then we will add, subtract, multiply, and divide fractions. This material, we do move through it pretty quickly. This is a section that we would generally spend a lot more time on, so don't get frustrated if it seems like too much. This is one thing that you're going to really want to practice over and over. So we are just going to be looking at a few examples of each. So this is something that you'll want to do for homework. You're going to want to practice each of these a lot. The first slide that we're going to look at shows us equivalent fractions. So hopefully these pictures with the yellow and the green help you visualize what that looks like. So again, you're looking at the whole rectangle to begin with. And if you're looking at just one side of that, which is yellow, you can see that that's 1/2. If you look at the picture below that, you can see it's the same exact rectangle, but now it's divided into 8 pieces. So if it's divided into 8 pieces and 4 pieces are shaded yellow, then that's 4 out of 8. But again, if you were to pick up that yellow rectangle and place it on the yellow rectangle above it, you would see that it's exactly the same size. So looking at the board, I'm going to write the same numbers just to show you how you would work that out. And here is an example using these little magnetic tiles. If you have 1/2 of a rectangle, it looks like this, 1/2. But now I have a rectangle that's divided into 4ths, and I have 2 out of those 4. That's 2/4. If I have a rectangle that's divided into 8ths, and I have 4 out of 8, I have 4/8. But you can see each of these is equal. If I place this 1/2 on 2/4, it's the same size. If I place this 1/2 on the 4/8, it's the same size. They're all equal. So if I start with 1/2, as long as I multiply the numerator and denominator by the same number, I'm finding an equivalent fraction. So if I multiply top and bottom both by 2, I get 2/4. Again, 1/2 is the same thing as 2/4. They are the same exact size. It's just that this one is divided into more pieces. Now if I take 2/4, which is 2/4, again, if I multiply both top and bottom by 2, now I have 4/8. It does not matter what I multiply by. If I do the same thing to top and bottom, I'm going to find an equivalent fraction. So if I have 3/4, if I multiply them both by 3, 3 times 3, 4 times 3 is 12. That means that 3/4 and 9/12 is the same thing. If I were to draw out 2 rectangles, the top one divided into 4ths, this one divided into 12ths, 3/4 is the same thing as 9/12. It's just a matter of dividing the unit into smaller pieces. So again, this is something you practice, and if it helps to look at a visualization, then that's what you want to do, whether that be something online or if you want to borrow tiles like this. There are many things out there that you can work with. Even just practicing with things that you have at home, like measuring cups, that can help you understand better. The next thing we're going to look at, before we get to adding and subtracting, you have to know your multiples. So again, you'll hear me say this in almost every single section. You really want to know your basic multiplication, which is 1 through 12, and you want to be able to divide those numbers as well. If you don't know these numbers, if you don't know your multiples, you can practice. And this is something that you memorize. This is one of those things that you just have to memorize and practice. So I have just some examples here. So when I say multiples, what it means is to multiply. So for example, 2 times 1 is 2. 2 times 2 is 4. So you just keep going up in numbers to find your multiples. So multiples of 3, your multiples of 3 would be 3, 6, 9, 12, and so on. So knowing those will help you with finding common denominators. So this next slide is an example of when you would use those multiples. So you have 2/3 plus 4/9. You must find a common denominator. What you want to remember in math also is you're not going to always have the same method for every operation. So when you're talking about fractions, when you're adding and subtracting, you have to have a common denominator. It's just a rule. It's different than multiplying and dividing, so keep that in mind. When you're adding and subtracting with fractions, you have to have a common denominator. So in this example, 2/3 and 4/9, you don't have the same denominator. One denominator is 3, and one is 9. So how do you figure out what your common denominator should be? And this goes back to knowing your multiples and then being able to find equivalent fractions. So if we look at 2/3 plus 4/9, two different denominators, I need to find one that works for both. So I'm going to look at my smaller number and think about what are the multiples. So 3 times 1, 3. 3 times 2, 6. Okay, so far these don't work because 9 is bigger. 3 times 3 is 9. That means that's my denominator because it will work for both. So now what I have to do is find the equivalent fraction for this original fraction of 2/3. So I'm using 9 as my common denominator. Again, when you're finding equivalent fractions, think of the word equal. They're equal. So remember, this is divided into 9 pieces. This one's divided into thirds, but they're representing the same amount. So whatever I do to the denominator, I have to do the same thing to the bottom. So if I change this from 3 to 9, that means I had to multiply by 3. If I multiplied this by 3, I have to do the same thing here. 2 times 3 is 6. So now all I did was I changed this 2/3 to 6/9. Again, they're equivalent fractions. I changed it because I have to have the same denominator for my original problem. So instead of 2/3, now I have 6/9. Now I can add 4/9. I can add them because I have my common denominator. That denominator stays the same, and you add the 6 and the 4. So here again here's my answer, but it's in improper form. In real life situations, you're probably not going to see 10/9. You're going to see it written as a mixed decimal or a mixed fraction. So 9 goes into 10 once with 1 left over. And again, you can try that on your calculator. So if you have 10/9, you just do 10 divided by 9. And you get 1.11, the 1 repeats. So whatever form your answer choices are, these two are the same thing. And so when you're taking a test, if you have multiple choice and let's say your answer is in fraction form, but this is what you got on your calculator and you're not sure, you can probably figure out that these two are about the same thing. So you know it's 1. You know it's one whole number, which is here. And then this 0.11, think of it again like 11 cents out of $1. It's closer to 0 than it is to 100. So 1/9 would make sense. So if you're in a rush for time, just try and look at it and make sense of it. And this PowerPoint kind of takes you through that step by step. Number 4 on this slide, it says, remember you must multiply the numerator and the denominator by the same number to keep the fractions equal. So number 5, 2/3 times 3 on the top and 3 on the bottom will give you your 6/9. And then this next slide just finishes that problem for you. So with adding and subtraction, you have to find your common denominator. So here is an example of subtraction with fractions. And first you have to find your common denominator. So you'll look at the example that's on your slide. So again, with these slides, hopefully you have them printed in front of you. You want to work the problem out yourself. I might not have every single step listed on the slide, so you want to write that out as we go along. So if I have 6/7 minus 1/4, I have to notice that these denominators are not the same. I have to figure out what is the common denominator. If you want to find your multiples of both numbers, that's probably a good idea. So first I'm going to do 4. And again, you don't necessarily have to write this out every single time, but if you're not sure of your multiples, then you would want to take this approach. So now I have my multiples of 4, and that took a little bit longer, but I can see that 4 times 7 is 28. But if I wasn't sure about my 7s, then I would write those out also. So when you do this, you can see that 28 is the only number so far that's common for both. None of these numbers work. None of these numbers are the same over here. So I have to find the lowest one possible that works for both numbers. So that means now I'm changing each of these fractions to an equivalent fraction using this as my common denominator. And I do that one at a time. 6/7. I have to figure out how to get from 7 to 28. What do I multiply 7 by to get to 28? Well, I know if I multiply 7 times 4, I get 28. So if I multiply this by 4, I have to do the same thing here. So now I have 24/28. That's my first fraction. So if you circle it, it might help you keep it straight on your paper. Now I have 1/4. Again, how do I get from 4 to 28? I had to multiply by 7. So now I have 7/28. So here are my two fractions. Now I want to plug them into my original problem. So 24/28 minus 7/28. Again, my denominator stays the same because I found one that works for both. And then 24 minus 7, I have 17/28. This one you cannot reduce. You always want to check and see if you can reduce it. 17 is a prime number. You can't divide it by anything other than 1 or 17. So there's no reducing here. Just always double check to make sure that you can't reduce or you don't need to reduce. So this next slide just takes you through that problem. So again, with subtraction, you're going to want to practice these. The more you know those multiples, the easier it's going to be. So you won't have to do all this work. If you have to do it in the beginning, that's okay, but hopefully as you move through the problems, you'll not have to do this as much. You'll know these numbers. Next, we are going to move to multiplying. So this first slide reminds you that multiplication of fractions is different than adding and subtracting. You do not need to find a common denominator. Multiplication is sometimes easier than adding and subtraction because you are just multiplying straight through. You're multiplying numerator times numerator and denominator times denominator. So this first example, number 1, has 6/11 times 2/3. So I'm going to multiply 6 times 2. I get 12. Multiply 11 times 3, 33. My answer is simply 12/33. Again, always check to make sure you don't have to reduce. This one you cannot reduce because 33, you can divide 33 by 11 and 3. So if you have 12 over 33, we're going to just look at this one on the board. You can divide both by 3. So 12 divided by 3 is 4, and then 33 divided by 3 is 11. That's not on the slide, but make sure you write that down. So it would be 4 over 11. So again, how did I know to divide it by 3? I looked at my factors. My factors of 12 would be 12 times 1, 2 times 6, 3 times 4. Okay, so I have 1, 2, 3, 4, and 6 as my factors. My factors of 33 are 1 times 33 and 3 times 11. So I do have one in common, and that's 3. So because that one is, you can divide it into both numbers, we would divide both by 3, and that would be our final answer. The next problem on that slide is 4/5 times 6 over 8. 4 times 6 is 24. 5 times 8 is 40. And then we have to, again, figure, do we have to reduce? One trick that can help you on some problems, if you have two even numbers, 24 and 40 are both even numbers because they end in even numbers. If it's 0, 2, 4, 6, or 8, it's an even number. So automatically you know you can divide them both by 2. So that's one way you could start it. So again, if you're not sure, one trick is to know that all even numbers are divisible by 2. So you could start reducing that way. But in this case, we are going to try and find the largest factor to reduce. So we have 24 over 40. We want to think about the largest number possible. So 24 has several factors. 1 times 24, 2 times 12, 3 times 8, 4 times 6. These are all factors, 1, 2, 3, 4, 6, 8, and 12. So which of these can I divide into both 24 and 40? That's going to be 8. (24) divided by 8, I know is 3. 40 divided by 8 is 5. So that would be 3/5. So again, you always want to make sure you want to see if you can reduce or not. And this is just an example of writing out all the factors. Okay, now we are moving on to dividing. Dividing is like multiplication in that you do not have to find a common denominator. So again, for dividing, you do not have to find a common denominator, but there is an extra step. Think about how addition and subtraction are opposites. The same thing is true for multiplication and division. The opposite of multiplication is division. So when you're dividing with fractions, you're simply multiplying by the opposite. So this first slide shows you what the word reciprocal means. So some questions, you'll see the word reciprocal. That just means the opposite or the inverse. So it's just flipping that fraction. That's your reciprocal. So we'll look at this example on the board. If we have 6 over 11 divided by 2/3. So the steps I think about are keep, change, change. And you'll see that on that slide, keep, change, change. This might help you. What that means is you're going to keep this first fraction the same. So just rewrite it. This division, you're going to change it to multiplication. Because again, I'm just multiplying by the opposite because division and multiplication are opposites. I'm going to flip this fraction. So 6/11 divided by 2/3, I just rewrote it as 6/11 multiplied by the opposite. Now you're back to multiplication, which means you're just going to multiply straight through. So 6 times 3 is 18. 11 times 2 is 22. Now think to yourself, can you reduce that? Well, right away I know that 18 is an even number and 22 is an even number. So for sure I can divide them both by 2. 18 divided by 2 is 9. 22 divided by 2 is 11. And that's as far as you can go with that one. So again, if you can remember, keep the first fraction, change the sign, and then change the next fraction by flipping it, then you multiply straight through. The next section talks about division still, but now you have an extra step because you're dealing with mixed numbers. So again, this one just is a couple extra steps. So if you look at this slide, you'll see this first example, 8/5 divided by 2 4/5. So you have the first one's an improper fraction because you have 8/5. And then the next fraction is a mixed number. You can't just divide or multiply with mixed numbers. You have to first change them to an improper. Okay, so again, I have an improper fraction. I'm dividing it by what we call a mixed fraction or a mixed number. I would be very careful with these and do it step by step. So I'm just rewriting this. I'm still carrying down my division. But now with this one, I have to change this to an improper. And the way you do that is by multiplying the whole number times the denominator. So 2 times 5 is 10, and you add the numerator. So 2 times 5 is 10 plus 4. And then that stays over that original denominator. So the denominator isn't going to change. It might change at the end when you finally reduce it, but for now, we're just carrying this down. So again, 2 times 5 is 10. 10 plus 4 is 14. So we're changing from mixed to improper because that's the only way you can do division and multiplication, by hand. Again, if you're studying for your GED, you would practice with your GED calculator, and you can do some of the questions on the calculator, but also you will have 1 or 2 questions like this that you cannot use a calculator. So you want to practice it both ways. If you are taking a test and you're only using a basic calculator, you cannot do this on the calculator. You can do steps of this, but you cannot do the whole thing from start to finish. So you want to know how to do this by hand. So I kept my first fraction, I'm still keeping my sign, and I changed this from mixed to improper. Now I can do my keep, change, change. So 8/5 times, change my sign, and now I'm going to flip this number. So when I multiply through, I have 8 times 5, which is 40. 5 times 14, which is 70. So I have 40/70. I want to reduce it. You want to find the biggest number possible to reduce by. I could start by reducing by 2 because they're both even numbers, but there's a better number to divide by that will help me get through it faster, and that is 10. So if I divide both by 10, I simply get 4/7, and that's my final answer, 4/7. Also, just remember, if you have a 0 on the top and a 0 on the bottom, you can simply cross them out. That's dividing by 10. So if I have 40 over 70, all you're doing is crossing out the 0 on both. As long as you do the same thing to top and bottom, you'll get an equivalent fraction, which is what you want. This isn't changing the value, it's just, this is broken into 70 pieces, this one's broken into 7. The next example on the next slide is a story problem. So again, I would work this out on your own, either on this paper or a different paper. So Ron has half of a tank of gas. If he puts another 1/3 of a tank into his car, what fraction will be filled? So this is going to be an addition problem because he put half a tank in and then he put a third in. So we want to know altogether how much that is. The problem is you have two different denominators. So you have to find a common denominator. Thinking about your multiples of 2 and multiples of 3, that's going to be 6. So each fraction, the 1/2 and then the 1/3, you're changing so that it has that denominator of 6. So 1/3 becomes 2/6, and 1/3 becomes 2/6. So now you can add 3/6 and 2/6, and you're going to get 5/6. So he has filled 5/6 of his tank of gas. The next story problem is multiplication. So Clarissa is trying to choose between two coats that originally cost $120. So both coats originally cost $120. One coat is on sale for 1/4 off, and the price of the other has been reduced by 40. What is the price of the less expensive coat? So they're giving you two different prices, but one they're giving to you as a fraction off, so you have to figure out how much is taken off. The other one is simply telling you, take $40 off. So for that one, you can simply take 120 and subtract 40. But for the other one, you have to figure out what is 1/4 of 120. When you're reading a story problem and you see the word of, almost always that's going to mean to multiply. So a fraction of another number means that you're going to multiply those two numbers. So 1/4 of 120 means you're going to multiply 1/4 times 120. So if you look at this example, and it's written for you on the PowerPoint, but also just looking at it on the board, 1/4 times or of 120. 120 is a whole number, so if you have to write it as a fraction, you just put it over 1. So any number can become a fraction by simply putting a 1 under it. This is the same thing as 120. But I want to multiply these two fractions. So this would give me 120, and this is 4. Again, I would reduce this. I could reduce both by 4, and I would have 30 over 1. That's a whole number. 30 over 1 is the same thing as 30. So that means $30 was taken off from that one dress. So if you look back at the slide, you'll see that example, you would take $30 off. So one coat is worth 90, the other one is worth 80. So obviously the one that is 80 is the least expensive. And because it's a story problem too, you want to make sure you go back and look at what the question actually is. Are they asking what is the price? Are they asking how much is taken off? Or are they asking how much will the final cost be? So after you do the work, you always want to go back and look for the actual question, because you might go through every step and do the math 100% correctly, but if you plug in the wrong number for the answer, then it doesn't matter, you have the wrong answer. So always go back and double check what the actual question is. What number are they actually looking for? So I hope this has been helpful, and I will see you in the next lesson.